So we completed till this point of magnetic field and all. We completed these parts and all, isn't it? Now, I'll start with basic examples first of all. Then I'll give you the tougher ones, okay? Question is, it's saying that let's suppose I have a rectangle, okay? And a current is moving in this rectangle in clockwise direction, okay? The length of this side is given. The length of breadth is also given. Question is, find the magnetic field at the center of a rectangle. Find the net magnetic field at the center of a rectangle. Yeah, this length is given 2 root 3 a meters, and this length is given twice a meter. Then find the magnetic field at the center of the rectangle. Do it fast. Tell me what will be the answer. Okay, I'll tell you one, I'll suggest you one thing here to understand first of all that many people think that, see, if I just construct this sides of a right angle triangle, means diagonals of right angle triangle, many people think that these angles are always 90 and 90, means something like that, and they divide into 45 and 45 degrees, isn't it? That's not correct, isn't it? Yeah, so these angles are not 45 this time, they are totally different. As you can see, this length, if this is 2 root 3a, that means that this length I can find out. This is how much? Root 3, isn't it? And if that is twice a, then from here to here, it is only how much? A, isn't it? It will be only how much? A. And let me mark it over here. So, if I consider this theta, this is perpendicular is like root 3 and base is like A. So, can I apply tan theta is equal to perpendicular by base? So, that means that this angle is 60 degree, then this angle is 30, isn't it? So, then this angle is how much? 60. Yeah. Tan theta is equal to perpendicular root 3a by base a. So tan theta is equal to root 3. That means it is equal to sine 60 by, got it? Why? This, if this is a is perpendicular. Tell me, what is this angle? Theta. Which is perpendicular side, Srishti? Is it attached side or opposite side? So this is perpendicular or not? Yeah. So root 3a perpendicular by base. A. So that is root 3. So this implies theta is equal to how much? 60. Is that clear? So for this, let's suppose if I mark it A, B, C, D. So there are four sides. Okay, but we can consider for two sides like C and D and A and B. The magnetic field strength should be same or not, because they are at the same distance and this angle is 30 and this angle is how much? 30, 30, 30. Yeah. So this is 60 and that is 60. Is that clear? So look over here. If I can find the magnetic field, what I'll do? Magnetic field at the center. O is magnetic field due to AB in a vector form plus magnetic. This is center O. So magnetic field due to AB, this part, then magnetic field due to CD, or you can say BC, then magnetic field due to CD, and then magnetic field due to AD. Now look over here. Current is going upwards, and this point is on the right hand side. So if I put my fingers like this way, and if I curl my fingers, then it will come like this way or not? Inside it, isn't it? So that means, let's suppose I call cross sign as inside sign and dot sign as a outside. So look over here. If I put my thumbs like this way, like it is downward, and if I try to curl my fingers, it will come like this way, isn't it? So it is upwards or not? Are you able to get me? Uh, yeah. So look over here. What is happening? What is happening? I think this magnetic field will become, as you can see that. So if I select this point, then this is inside the plane for this AB part, but for CD part, how it will come? No, it will be also inside now. Thumb, if it is thumb inside, and if I rotate it like this way. Acha, if you feel like since okay, I'll tell you one trick how to write it. When I was discussing magnetic field, I told you to write L cap cross R cap, isn't it? Okay, so L cap. Now you see that here in first part AB, for AB, L cap cross R cap. L cap is along which direction? J cap, isn't it? And R cap is along I cap. J cross I is minus K cap or not? Yes. For similarly for CD, L cap cross R cap is what? L cap is along which side? If you look over here, that is minus J cross minus I cap. Are you able to get? So minus minus plus, and J cross I is once again minus K cap. For AB, AD, for AD, this is L cap cross R cap. L cap is along this time minus I cap, but R cap is along plus J cap or not? I cross J is minus K cap. Are you able to get me? Similarly, for BC, L cap cross R cap is equal to what? L cap, this is L cap I cap direction, but R cap is minus J cap or not? So this is once again minus K cap. Are you able to get me? All these directions are magnetic field are along minus, so that means they will get added. Yes, and magnetic field of AB will be similar to CD, while BC will be similar to AD. Are you able to get me? So we can write the net magnetic field O, 2 times of magnetic field of AB plus 2 times of magnetic field of AD, and along minus K cap direction. Are you able to get me? So B naught vector becomes what? 2 times of magnetic field due to AB. So magnetic field due to AB is also mu naught I. What was the formula of a straight line? Mu naught I by 4 pi I by r square. Mu naught I by 4 pi. R is how much? R is nothing but root 3a or not? I think why r square I have kept over here. Oh, if I consider the direction. Okay. Now I'm just writing the direction in the form of unit vector. I'm not writing total r vector. So I'll just write r. Are you able to get me or not? So this is what. Yeah. Because here it is a scalar. Now I have already included the direction into sine for AB. Alpha is 30, beta is 30. So sine 30 plus sine 30. Is it clear? Plus twice BD. So twice mu naught I by 4 pi. For BD or for AD, the R is only A length, isn't it? 4 pi A. But this is sine 60 plus sine 60 minus of K cap. Are you able to get me? So can you solve this to find the total magnetic field or not? Okay, so that's your task. Are you able to get me? So see, if you are following right hand thumb rule, that is also okay. But if you are not following, and if it is asked to write the magnetic field direction, then people get usually confused. So that's why I follow L cap cross R cap. Are you able to get me? Okay. Let us move to next question. It is saying that I have three very long wires. These wires are very long. Okay. In this the current is going upwards. In this the current is going downwards. Okay. And in this there is no current. If I select random points A, B, C, question is find the magnetic field at all these points A, B and C. If all are at the same distance from each wire. Find the magnetic field at A, B and C. Do it fast. Infinite lengths, very long wires. We have, remember that, very long wires. Uh-huh. Infinite length. That means alpha is equal to beta. Yeah. So look over here. If I want to find magnetic field at A, it will be due to, let's suppose this is first wire and this is second wire. So it will be due to magnetic field due to first wire plus magnetic field due to second wire or not. So due to first wire, this is at distance A. So what is this? Mu naught I by 4 pi A. So 2 sine 90, isn't it? L cap cross R cap. L cap is along J cap. R cap is minus I cap, isn't it? Plus due to B2, this distance has been increased or not? This is A plus A plus A, 3A. So mu naught I by 4 pi into 3A, 2 sine 90, and L cap is still, L cap is this time going to change. It is minus J cap cross minus I cap. Are you able to get me? So this is mu naught I by 2 pi A, and this is J cross I. I cross J is K. J cross I is minus K. Minus minus plus. So it is K cap or not. And this is mu naught I by 2 pi into 3A. And this is J cross I minus minus plus. That is also minus K cap. Are you able to get me? So answer can be directly written as mu naught I by 2 pi A 1 minus 1 by 3 K cap. Is that clear? In simple terms, mu naught I by 3 pi A K cap. Are you able to get me? Similarly, magnetic field at B, calculate it. It will be also magnetic field due to first wire plus magnetic field due to second wire. But everything is same now. Mu naught I by 4 pi A 2 sine 90. Distance is same or not? A, and it is J cap cross I cap plus mu naught I from here. Once again same 4 pi A 2 sine 90. Got it? Then J cap is minus J cap cross minus I cap still. Are you able to get me? So mu naught I by 4 pi A. This is how much? J cross I means how much? Minus K cap plus mu naught I by 4 pi A. Sorry, into 2. J cross I is minus K cap. So it got added, isn't it? So answer is mu naught I by pi A only minus K cap. Are you able to get me? Similarly, it's your task to find for point C. Whatever you have got over here, it will be just opposite of that or not. Yes. So you just do it. Are you able to get me? Okay. Is it clear? Third question. If I have two perpendicular infinite wires, wait, let me draw like this way. Okay, semi-infinite. This is 0 comma 0 comma 0. The current is going like this way. Question is find the magnetic field at coordinates a, that is a comma 0 comma 0, b, which is at minus a comma 0 comma 0, and at some random point c, which is having coordinates 0 comma 0 comma a. Find the magnetic field at all these points. Tell me. Yes. Tell me fast the answers. You do it, I'll just bring my water bottle, okay? Tell me what will be the answer. For A, what will be that? If I see in reality, if you check, so A is at distance A from the this wire, isn't it? Now, if I consider this end, so this angle is going to be 45, isn't it? Oh, I give the wrong coordinate. Sorry, this is A comma 0. Okay, and this is minus A comma 0. So this will be A, and this is also A. So this angle will be 45 or not, while other angle will be 90. That is the meaning of semi-infinite or not. So if I write magnetic field at point A, what will be that equation? It should be exactly equal to simply mu naught I by 4 pi A sine 45 plus sine 90, isn't it? Are you able to get me? Now, for this, L cap direction is minus I cap, isn't it? Cross R cap direction is J cap, isn't it? Now, due to the another wire, once again mu naught I by 4 pi A. This angle is also going to be 45 then, and this length is also A. So once again sine 45 plus sine 90, L cap minus J cap and J cross I. Okay. So both are same. I cross J is what? K cap. So minus K cap also here also I'm getting minus K cap. So answer is what? Twice mu naught I by 4 pi A. Sine 45 is 1 by root 2 plus 1 minus K cap. That's your answer. Magnetic field at point A. Is it clear? So this is equal to simply. Similarly, magnetic field at, if I want to calculate at B, if I join like this way, now see, for one of the wire it is a semi-infinite case, but for other wire it's not like that, isn't it? If you look into point B, how it is. Basically, if I took these wires, then point B is like this way, isn't it? For one of the wires, this wire it is semi-infinite, but for this wire we do not know. So how to do that? Tell me how to do that. 1 minute. Okay, can you hear me now? Hello. Other one, how to find it? Tell me. See, for this it is semi-infinite, but for other one, how to find it? Hello, can you hear me? Array, there was a call, that's why. Because still it's not connected to perfect Wi-Fi. So for this wire, it is infinite, but for other wire, it is not semi-infinite, isn't it? So how to do it? See, can I create it? Can I create it? Listen, listen, listen. For the other wire, what? So for the other wire, it can we can create a triangle like this way or not? Hello, can you hear me? Hello. Okay, okay. Now you can hear me. So this length is A, isn't it? And if we look over here, if this is 45, then this angle is also how much? 45. So for this wire, for this particular wire, one angle is definitely 45. Another angle is 90 degree or not? Because is this is following like this kind of appearance? Is it on? Is that is following that kind of appearance or not? Arey Baba, yes or no? Tell me. Okay, 1 minute.